Remember from the work that you've done in science on gases that we're surrounded by air, which is made up of lots of gases. Air is a mixture of many gases, and it's useful to us and all of the living things because we breathe it. If you want to find out what something is made of, that is what chemicals it's got in it, then we have to analyse what that substance is. Suppose, for example, you find a packet containing white material behind some bricks in your cellar. Right, Rosie says, "What is cocaine?" "What, some of that." Right? And you say, "Well, I'm not sure it is cocaine." How can you find out? You can take it along to a place where they will analyse it chemically. They'll do all sorts of chemical tests on it, and you'll come back with the good news: it's a pound of salt. Right? Sodium chloride. So if we want to analyse things, then we can do that, and we can do it with gases. Now, what I've got for you today to look at is a mystery gas. No one's quite sure what it is. It's in here. And notice that I've got it in a gas jar. And what's odd about the gas jar? There's nothing in it. Well, it looks as though there's nothing in. There is, in fact. It's the same colour as air. That is, it's got no colour at all, so you can't tell it's there. Look at the way I'm holding the jar. I've got the jar upside down. That might tell you something about the gas that's in there, but we'll sort that out a bit later on. Let's see what you can remember about gases. First of all, I think before we do anything else, I'll put these on. And, scanning camera. Now, as usual, when I do experiments, it's famous with the 50 people that whenever I do experiments, they never work. Inside there is some copper sulfate solution and some zinc. The copper sulfate simply speeds the thing along. What I'm going to do is put some dilute sulfuric acid in. And you can see that as soon as it goes in there, it starts to behave like fizzy pops. Now, you've all done this. It's going a bit slow, so what we'll do is warm it up a little bit. I'll point it away from you.
There's a clippers there.
And what we'll do is save the gas up.
Should use the clippers.
Oh, I should use the clippers. Well, I'm going to be a bit risque. There we go. We'll save the gas up by keeping my hand over the top, which I suppose I shouldn't do either, but it always seems to work very well. And if I put that gas in the flame now, nothing will happen. Pop. Did you hear it?
Yeah.
Now, you all know what that gas is, don't you? What is it? It's what? Hydrogen. Well done, Donna. So we know that if we have a gas and we set fire to it in air, if it explodes, it might be hydrogen. What I want you to do later on with your mystery gas is to take some of that gas, put it by a Bunsen flame and see if your gas explodes. If it does, it might be hydrogen. It could be something else, but it might be that. In these two jars is another gas. You say, "Oh yes, you're pulling my leg." Well, I'm not, because the gas is exactly the same colour as air. That is, it's got no colour at all. Watch. Let's take this jar and make sure that it's empty first. Now, I make sure a jar is empty of gas by filling it with water. As the water goes in, the gas comes out, and then what goes back in? Air. Air goes in. So there's air in, no gas. Here is some lime water. Now, you all say, "I'm not lime water again. I'm sick to death of lime water. Every time we brew lime water." I put lime water in there and shake it up, and hey presto, nothing happens. What's lime water a test for?
Carbon dioxide.
Two lovely blue eyes. Carbon dioxide. Let's take the top off this jar and hold it there, like that. The jar that's got nothing in it. Right? Now, I actually know there's something in this jar because I put it in at the start of the... I put it in at the start of the lesson, you see. And you can see now that the lime water has gone cloudy. So what was the gas in there? Carbon dioxide. What else does doing that tell you about it? Yeah, I've had a little bit. Yeah. Yes? It's going into that one, so it must be... Think of the weight. Heavier than air. So there's a gas, carbon dioxide, which is 1, heavier than air, 2, turns lime water. Now, I've got here as well some boiling tubes which are full of another gas. I'm going to take one of these splints and get it burning nicely. There we are. And what I'm going to do is put that, blow it out first of all. That's lovely, thank you, birthday time. And put it in the tube, and look what happens. Blow it out again. put it in the tube, pop, lights up, blow it out again, put it in the tube, there'll be enough. Go on. And it lights again. Now, if you've got a gas which relights a splint that's smouldering like that, we say a glowing splint, then the chances are that gas is
Oxygen.
oxygen. Oxygen. So we've got hydrogen, we've got oxygen, we've got carbon dioxide, all gases that we've done today. Now what I'm going to do is put my goggles on again because this one's a bit nasty. Now I want you to do that test with the mystery gas that I'm going to give you later on. Let's take some more of this oxygen out of here. All right, Donna. Let's take some more of this oxygen. This time I'm going to use a piece of magnesium ribbon. Now, what you have to do with this is make sure that the ribbon is straight and you only light the tip of it in a blue flame. And don't stare at it because it gets quite bright. This is what the television camera loves because it sends it bananas. What I'm going to do is place that near the front so that we can see it. Can you see it around there? If you come and just nip around the back. Which is the tube? That one. Light that in just the tip of the flame, and as soon as it's ignited, place it in there, and look at that. Wonderful. A really bright flare up, right? And you'll see also left in the tube there, which is rather hot because of the strength of the reaction, a kind of white powder. Now I can take that off because the danger has passed. But if I take a dropping bottle, and this is a dropping bottle with litmus in, notice that when that peg and those bumps are lined up, it drops. Drop your peroxide bottle, there we are. If they aren't lined up, it doesn't. I'm going to cheat and take the top off because I want that to go in a little bit more quickly than it otherwise would do. And let's see what colour that goes inside there. I think you can see that it's got a nice blue colour. Now, if that turns blue with litmus, thank you, we have an alkali. Aren't they brilliant students? Here, in this jar, is some more carbon dioxide. Down with that, please. And if we put the litmus in and try it again, this time, instead of it turning blue, it goes a sort of dark blue red colour. We call it claret. Good old Aston Villa, claret and blue. I had to get that little plug in. Alright, now, that's a gas that's an acid. I want you to test your gas as well to find out if it's acid when you do the tests a little bit later on. Alright? Now, so all I'd like you to do then now is to look on the sheets that you've got there and go down the list and sort out what's what. I'll help you sort them out so that we can find out what the various tests are. So if you'd like to go back to your places now. Now, underneath there, you can see A, B, C, D, E, F, G, H, I. Is that right? Is it down to I, is it? Yeah. You will see some sentences about gases. Put the letters of the sentences and just write the name of the gas next to the letter. Oxygen. Well done. Oxygen. E is oxygen again. The gases crop up more than once. Oxygen. A gas which is not used when things burn in air is. Now come on, anyone who's done C16, how much air is used up when something burns in a container? You put the tube on the burning piece of wood, the flame goes out and the water goes whoop, like that, and you measure it. What's the gas that wasn't used up, that was left, but used then? Nitrogen. Let me just show you something. Years ago, they used to use nitrogen for deep sea dives. Yep, and oxygen, air for deep sea dives. If a diver goes deep, what happens to the pressure? Goes up. So the gas is forced into his bloodstream by this high pressure. Oxygen's okay because he uses the oxygen. What's the matter? I haven't split the two, doesn't it? It's all right. Oxygen's okay because he uses it, doesn't he? But nitrogen he doesn't use, and under that great pressure it dissolves in his blood like carbon dioxide does in fizzy pop. Yes? What happens when you undo the top of the pop bottle and release the pressure? Now imagine a diver who's been breathing this air with nitrogen dissolved in his blood coming back to the surface. As the pressure falls, what's the gas in his blood going to do? Fizz up. Exactly. Now imagine what cramp is like everywhere. Now you have it in your legs, when you go swimming or running or cycling. Yeah? Imagine that pain all over your body. So what does a diver who's got that pain all over his body do? Eh? He goes, oh! Right? and they call it the bends, because it makes him bend up, right? How do you cure someone like that? Well, you slap another air cylinder on and send them back down again, and you bring them up slowly. Or else you put them in a decompression chamber, pump up the air pressure. They don't measure pressure in decompression chambers, in pressure, they measure it in depth. The same pressure as you would be if you were 100 feet down, 200 feet down, 300 feet down, and they gradually release the pressure. There's a solution to that problem, but we'll talk about that near the end of the lesson. Okay, what's the next one? Lime, water, milky. Quick, write them down, hurry up, we're running out of time. Carbon dioxide, a gas which burns non-metals to make acidic oxides. Well, if it's oxides, it must be oxygen again, right? And a gas which burns with oxygen to make water only. Think of the formula of water, and the gas is hydrogen. Brilliant. Here are the answers. Check. A, oxygen. B, hydrogen. C, carbon dioxide. D, ammonia. E, oxygen. F, nitrogen. G, carbon dioxide. H, oxygen. I, hydrogen. Okay? Right. Now this is what you tick if you want to. Yes, listen. There are set up 4 workstations with Bunsen burners. Some can use the place I was originally, that need to clear up. There's one there, one there, one there. Arrange yourselves in groups. So you've got 2 groups of boys, 2 groups of girls. Just a job. You need in each group 1 pair of goggles, 1 splint, I'll give you some more later on, 1 piece of magnesium ribbon we'll cut for you, the litmus you can borrow, the lime water you can borrow, the gas jars I will give you, and we can top up over here. Right? On that sheet of paper, hang on a minute, let's do this first. On this sheet of paper are some tests which I want you to do on each gas jar. We can fill in the first one all together. Number 1, the gas is something that air. Write the answer down as a sentence, please. The gas is the air. So we write, heavier is it? No. The gas I'm going to give you in the jars. Remember what I said about the way the gas jars were kept up?
Yeah.
I've got them upside down. Yes? Here they are, look, here are the gas jars. This gas jar is stored with the open end at the bottom to stop the gas escaping. So which way is this gas trying to go? Ooh, what? So you see that? Which way is it get off? It's trying to go oof. It's trying to go up, right? Go get off, but the thing keeps going up. So what is it? Lighter than air. So we write down the gas is lighter than air. Now after you've done each of those tests, 1 person per group do each one, or whatever you like to organise it amongst yourselves. Put the answer as a sentence underneath that, and which will build up a little dossier about this gas. You know what a dossier is? Yeah? Darren Rhodes, 6'6", lantern jaw, dark hair, on shirt. No? A dossier, what it's like. And we'll see if we can find out. Now this is tricky, this gas. I'll warn you now, you will find it most annoying to do anything on this. I'll warn you now. Most annoying this gas is. Okay, go to it. Now wait a minute, just one more thing. If the gas jar's on the bench, don't pick it up, slide the cover off like that to use. And if you've got to use it the right way up, like putting lime water in, then try and pour the lime water as if the gas wasn't looking. So you slide the top off a little bit, get it in and shove it again, and then shake it. Ah, so it'll be out, right? It'll be off. Okay? There you go. So, that's what we're doing. Okay, off you go.